So we're privileged and welcome today to have Professor Antonio Cisternino from the University of Pisa, who's been doing some work on OS10 and his environment. So he has a short presentation here that he's going to walk through live from Italy, if all goes well as a demo towards the end of what he's been able to develop. So Professor, the floor is all yours.
What I want to talk to you today is a project that actually is part of my applied research project, because actually I'm a researcher and a professor, but also a member of this IT center at the University of Pisa, that is a center that has become a solution center for Dell, and actually one of the center is to do R&D research in the style of industry rather than universities. So actually, as an academic, I have my formal theory on whatever research, and then I also play with cloud computing, hyperconverged things, and of course networking, which is a really interesting topic today. My background is from programming mostly. I started doing seriously networking in the last probably 4 or 5 years, but whenever I look at the network, I tend to see the programming world. So in this software-defined networking, I feel very comfortable because I have this background in programming. So what about today? So today I want to present the Internet IX project. It's Internet of Everything Interconnection Environment, which is a project that focuses on Internet of Things, which is of course a cool topic, and I truly believe it relates to the networking in many ways. So the first motivation is IoT will be huge. I mean, they estimate 25 billion devices by 2020 and all these beautiful things. But if you think I'm not worried about the endpoints. I mean, the IoT devices. I'm not an engineer, and making an IoT device means essentially that you run a standard OS, more or less, and a standard software stack, so that you can Python your code on the device and make a beautiful HTTP connection to somewhere else without worrying to standard and dedicated protocols. So in this respect, I truly believe that the most important part is how do we deal with the large amount of information that this device will produce. And of course, there are bandwidth issues, especially if you try to aggregate all these messages down to the cloud, and this led to the Fog initiative to start thinking about distributed clouds that handle all these volumes. But I also think that we have problems in the way we manage the choices by which a message gets delivered to an endpoint into the network rather than another one. And I strongly believe that we need some way to route this. I'm making an assumption. So I would expect that this device will probably stream using some video streaming on some other protocol, a bunch of data, and then they need to coordinate by means of messages. And this, in my opinion, it's likely that will be HTTP and REST or JSON messages. So it's well-established protocols. You have all the benefits of the web. You can easily do web interface to your device. So it's very natural that that would be eventually the technology. So my question is, how do I decide whether a JSON message containing the temperature of my room should be sent to my local storage rather than on the cloud? How do I, as a user, I'm in control of this information flowing and going up and down out of my house? So actually, if someone hooks in my thermostat, smart thermostat, smart whatever, actually can learn things about me and maybe enter my house when I'm not home. So there are a lot of security issues and mostly and privacy issues there. So I also have a problem that I don't think it's viable to use the firewall approach in which I give a name to the endpoints, and then I say, okay, you go from here to there, and you're allowed or not. Because actually, if you have 1,000 devices in an industry, hundreds in your home, who's gonna write and compute those rules and upload these? So I think we need to start entering inside the content message and not looking at the metadata. So the goal of this project is trying to define an IoT vendor-independent runtime is capable of letting vendors of the devices to insert modules so that they can provide custom code control the particular devices in a single place, and capable of supporting the process of these JSON messages in a well-defined framework with some guarantees about the content, especially for the user. So that's the core thing. The other thing that is a collateral of that much, and it's part of the reason because I'm talking to you today, is the fact that actually the network switches are not considered part of the IoT. But if I'm able to run a runtime such as this onto a network switch, I'm capable of essentially transform even the switch into an IoT device, which is simply a device which is meant for delivering information along the way rather than actuating or reading some sensors. So I truly believe that this will simplify the vision that actually is I have an edge, and then inside the edge it's a traditional infrastructure. So those are the motivation and the goal. And for this reason, the architecture I have in mind in writing this thing is that I have this IOX, which is responsible for receiving JSON messages from typically local devices. Vendor modules can interact and intercept messages dedicated to them. And then you can either forward the message to somewhere else, so towards the cloud, to some other private cloud, or send back some message, or interact with the local device. And in principle, one of the design principles I'm following in the design of iOS is that it will be capable of running on even smaller devices. I'm not sure I'll be able to run on Arduino, but I have a very little requirements that allows to run this thing. But of course, you can run it on, on a gateway for IoT, such as the Dell gateway that you will see in demo we set up, or onto the control plane of the switch running OS10, or on a server. So I got a sort of semantic overlay for routing these JSON messages across the network to decide where some information should be passed. Another thing that is mentioning is that actually runtime will eventually be capable of annotating, so adding new keys to the JSON messages. This is important because this allows intermediate node of the processing to tag the information with some extra information. So instead of marking all the devices of my house like these are the devices of my house, I can try to say, okay, I have a gateway, all the devices communicate with the gateway, and the information gets labeled by the gateway with the fact that they are leaving my home. So if someone steals my device, it's not a problem because it's maybe gets connected to some other thing. So I don't really care about the identity of this device. So what is the iOS architecture? So the architecture is based on .NET. I'm a fan of .NET. I'm a fan of a programming language, so it is unbiased, but there are deeper reasons than that. I mean, currently .NET has been fully open sourced by Microsoft. It runs pretty much on every platform. The support on Linux is mature, and that's important. It's type safe, and it has the runtime internal mechanism to isolate part of the code against the other part of the code. So it allows me to have a better isolation of the code that runs in the runtime than having a flat environment, such as what happens in Python or JavaScript or other scripting languages that you may run on these things. Here. Hello?
Yeah, keep going, Antonio.
Okay. No, I've got a pop-up from the link, the client, so I suspected that I was speaking to no one. And F# is a functional programming language, and it's beautiful for inline processing. It has type inference, so it allows us, the programmers, to overlook typing. You don't have even compile if you use the F# interactive. So there is a top-level command line in which you can type in command and execute on the fly. And then I'm putting a piece of research that is that a graduate student of mine that is named Andrea Canciani is doing, that is called Reacted, which is a framework for reactive programming, and you will see that this is a crucial part of this architecture. As you can see from the picture, the idea is that messages enter and are delivered to a common infrastructure, which is the message processor, and it's the only one looking into the messages. Then the user will be able to set up filters on those messages that are not dependent on the modules. I can go through all the keys in my JSON message and say, I don't want that the name of my niece goes out of my house, no matter what. So message will be it will be possible to expect messages entering the processing chain and exiting in case those are sent outside the local network. And the other thing that the runtime allows is to act on the local device. And this is important, for instance, when you run on a network, because this allows to not only process messages, but also control and take actions for several reasons. In the example we will see in the demo, there is an interesting use case. And then, as you can see, there are modules that are the orange box that have to abide to some rules, of course, for programming. And they are bound, since I'm allowing HTTP requests, they are bound to HTTP path. So each prefix of the path defines the module uniquely. So that's one of the assumptions I'm making. And modules, of course, can offer HTML5 UIs. In this case, it's very easy to do. So it's possible to quickly deploy UI interface of this thing. Okay, so this is an example of a fully
Antonio, let me
working,
pause you there and check with the audience, see if there's any comments or questions so far. Okay. Please, Antonio, go ahead.
Okay. This is an example of a fully working module. So this is completely entirely private. So I assume that you're not familiar with the syntax of this language, so it doesn't really matter. But the key point here to notice are the following. First of all, you define a type, which is your module, that inherits from a given class, and this is the typical frameworks. The module declares its favorite namespace, in this case the HW, that means hello world, and this will be the prefix that of the web URLs appear on the URL, and then of course some description. So whenever the module gets loaded, you can do some proper configuration, and in this case, the module is not hooking into the request, simply telling to the framework, I want to register the event hello under HW. So this is a pattern match on the URL the user or some device is typing into the processor, and the system returns something that is an event. So everything becomes event. And in case I'm mapping 3 URLs to 3 events. Then I define this net. This is where the React magic comes in, because this is essentially a very compact notion for defining a workflow. So this plus here, just below the net, means loop forever, whatever there is inside the braces. The first step, workflow is hello. Whenever I get the hello event, I simply send back hello dear. Then there is the hyphen, that means this is next step. And then there is another plus, which means another loop, because actually we enter in the chat loop. And in chat loop, I simply get the content of the message, and I reply, I disagree on whatever the user is sending me. And this loop is forever unless I get a buy message. In that case, the loop exits. So everything is asynchronous. So this loop is not a control flow. I mean, the structure is actually a Petrinet, is the formal framework that is behind the scenes that gets updated at each event. So this is not costing, it's few bytes, and the library is very lightweight. It's, I think, less than 1,000 lines of code. So there is no real overhead in this process. It's just a sort of finite automata state that gets tracked by this thing. And this means that if I'm in the chat loop, the system will not allow any hello message. So hello messages will be simply ignored because the system is not in a state to accept a message. And whenever I get the buy, of course, I exit the loop, and then the buy prints bye-bye, and since there is a bigger loop, the system goes back to say hello. And then. So networks are, in fact, data structures that you can activate explicitly and put it in run, and you can even dispose. So you can dynamically change the set of URLs that some module is exposing to the rest of the world. And this is important in terms of security, because actually this is a language that can be formally verified. So actually, if you want to be sure of some given property about the message handling, this reduces the surface of an attack, because some of the URLs become void. This is guaranteed by the system.
Okay. Hey, Antonio, this is from Santa Clara.
Yeah.
Quick thing, we have a hard stop here in 10 minutes in Santa Clara. So maybe if you could just wrap up and sort of give us a conclusion, I think it'll be good for the audience. And maybe if you want to ask any questions, I think that would be good as well to sort of wrap this up.
Yeah. So now there is just a really quick demo, 3 minutes. And then I will discuss what are my consideration about and how and what is the role that OS10 played in this thing. So, I'm trying to now. Steve, can you go make the video start?
Yeah, Antonio, I think in the interest of time, let's get to the end here. So
okay,
maybe you can...
That's okay. No problem. So I simply tell what we did on this thing. That actually it's working. So actually we have this runtime written in .NET running on a Dell gateway for Internet of Things that is attached to a fingerprint sensor. Fingerprints gets recognized. The gateway recognizes a fingerprint and send a JSON message to the software running on the switch. The switch decides whether to, so it is the switch deciding whether to not allow or not someone into the room, and it simply logs and sends back some answer that actually opened the laptop, which is in production today. So why this is interesting for the OS10 operating system? And so first of all, it's been incredible for me as a programmer being able to deploy on top of the having a full Linux switch, full Linux prompt to work with. So I was able to develop and test on any system, easy to develop and install the packages. Particularly the mono package that was crucial for me has been installed in minutes rather than in other experience I had on different operating systems. It was a nightmare in this case. It was just apt-get mono complete install, and it was up and running in minutes. That was on the management side. Then the cross-platform, because actually I developed the full thing on Visual Studio on my Windows Surface laptop, and I simply SSH onto the switch and drag and drop the executable on the file system of the switch. and everything was fine. But, and that was interesting, I found a bug in the mono runtime on a particular sequence of bytecode generated by my program, and so actually I was stuck, and I was able to compile actually on a Mac platform a different version of mono, the latest, which has already fixed the bug, and that worked in minutes, and I was up and running again without any problem. And I developed using leveraging on the CPS interface that allows you to hook into the core of the switch. I was able to perform actually status queries, but the idea is that whenever a security breach is detected on the system, the switch is able to configure networking of the room so that I can either create an honeypot or shut down the ports because some security breach is detected. So that's an example of acting on the switch. So to conclude, we believe that this kind of messaging will be the core messaging for the IoT. Security is important, so it should be first class. So in designing this runtime, I'm essentially going through to paying attention with security fees at first, and not just only HTTPS, and so it's secure. And my personal goal is to contribute to provide some runtime that eventually will emerge to make this IoT communication something more concrete rather than a mess it's now, and it's essentially a bunch of passwords. So today I'm in the process of posting on GitHub source. If someone is interested on iOS on Twitter, my
Antonio, unfortunately, we'll have to sort of stop here. Thank you for your presentation, and the slides are available. Anyways, it's a new and interesting use case of an IoT app essentially running on one of our switches and showing you how fingerprint scanners in university campuses can be controlled using the CPS API that runs on IoT. And this was thanks to Professor Antonio. He developed this app himself using F# programming language, and he's been collaborating very closely with us and giving us feedback on our operating system as well as we are sort of evolving the APIs. So